Arguments are set up in a particular way that have a specific meaning that must be translated properly to be able to find its truth values. Unlike arguments that are given in symbolic form, some arguments are given in word form as statements. To be able to find the truth value of these arguments, honestly, it's best to translate them into symbolic form, then proceed to make a truth table to find the truth values. So when you do that, end up with one of two possibilities. You can end up with a valid argument, which is where all truth values of the conditional statement are true, or you can have a fallacy or an invalid argument, where the truth values of the conditional statement are not all true. Meaning if you have even one false statement for the argument, then it is invalid. Otherwise, if they're all true, then it's a valid argument. Typically with these, you can ignore past, present, and future tense if they arise within the arguments. So let's do a couple examples, see how it goes. Let's see. There must be a dam or there is flooding. This year there is flooding. Therefore, three little dots means therefore. This year there is no dam. So first off, let's put it into symbolic form and let's write it out as P and Q. So P, there must be a dam, and we'll say that Q is there is flooding. So there is flooding. So there are my statements written in symbolic form. Now let's translate what this argument is. So there must be a dam or there is flooding. So I would say that this is P or Q. This year there is flooding. We're going to ignore the tense this year. There is flooding, so Q. Therefore, this year there is no dam. There is no dam. So this would be not P. Now it's in symbolic form. We can actually write it out as what it would look like as a complete symbolic form without it being an argument form. So we can say that P or Q and Q, therefore not P. So that's what this looks like if you put it out in our more traditional truth table form that we're used to. So now it's written out, we're going to write our truth table. So I'm going to bring up my truth table here. I already have it set up and ready. And that's the next example. We'll just ignore that for now. So let's set up or fill out our truth table. So not P, so false, false, true, true. P or Q, so true or true is going to be true. True or false, true. False or true, true. False or false, false. Now we're going to do P or Q and Q. So true and true is true. True and false is false. True and true is true. And then false and false is false. Now we're going to go to the last column, which is the entire argument, the entire thing. So we're going to have this column implies not P. So true implies, true implies false is false. False implies false is true. True implies true, true. And then false implies true is true. And we can see here that we have all trues but one false, which means that this is invalid. Go on to the next one. If it is cold, comma, my motorcycle will not start. My motorcycle started, therefore it is not cold. So again, let's set up our P and Q. So P, so we're going to say P is it is cold. I'm going to say that Q is the motorcycle started. Even though that says not started, I'm going to keep them all in the, affirmative or positive way. So I got P and Q. Now I'm going to translate this out. So if it is cold, my motorcycle will not start. So this comma right here, that comma essentially means a conditional statement. My motorcycle will not start, so that would be not Q. My motorcycle started, so that would be Q. Therefore, it is not cold, so not P. So there it is in symbolic form. Now again, I'm going to translate it one more time. So again, P implies not Q, and Q. Therefore, so again implies not P. So there is my setup form to write my truth table. Again, this is much easier to work with than the original. And so now I know what it looks like. I am again going to bring up my already filled out truth table just to make life easy. So I already have P and Q filled out. So not P is going to be false, false, true, true. And then not Q is going to be false, true, false, true. And now we get into the rest of it. So P implies not Q. So true implies false. True implies false is false. True implies true is true. False implies false is true. And false implies true is also true. Next column. This column here and Q column. So false and true is false. True and false, false. True and true is true. And true and false is false. Now I get to the whole thing, last column. So this column here implies not P. So false implies false. False implies, false implies false is true. False implies false is also true. True implies true is true. And false implies true is true. We have all T's, which means that this argument is valid.